guys, everyone. Hi, good evening, everyone. Today I'm with my team. Hi. Today I'm with my team. We're going to present to you guys about input and output architecture by our teams. So this is our team. We will introduce to you by one. So starting with Ihsan, just introduce yourself.
Hello guys, my name is Ihsan. My full name is Muhammad Ihsan bin Kamar Zaman, but you can call me Ihsan. So next,
I'm the presenter here. I'm Muhammad Irfan bin Rizal. My matric number is B0324107072.
can I add my metric number? Can
Sure then.
okay.
Go ahead, go ahead.
In Malay B032410707777.
Okay, my name is Muhammad Irfan bin Zulkifli. My metric number is 32410773. Okay, you can call me Faris Irfan.
My name is Pabana Anak Jampong. My number metric is B0324410019, and nice to meet you.
Hi guys, so this is
Next.
our team for the presenter today. Hi guys. So let's move into the
Hi.
next slide, please. So the content of table that we are going to present today is what is an output architecture? Key the components that make it work. Data transfer technique, challenges engineers face, and how they solve them. Okay, let's go to the move. Next slide.
Alright. Okay. So first of all, what is I/O architecture? I/O architecture is the framework that allows communication between the CPU and external devices such as keyboard, monitor, and storage drivers. Driver. It as a bridge to ensure that data can be sent and received correctly between the system and peripheral. So why is I/O architecture important? Because without it, the CPU will not be able to understand device command or data, making the computer function because no input or output could be processed. So, uh, uh, next slide.
This key component. To understand how input and output works, we need to know three main components. Number one is input-output device. Number two, input-output controllers, and number three, input-output interface. So number one is input-output device. Device we such as like keyboard, monitors, and printers. For input-output controllers, these are special chips that control communication between the CPU and external device. For example, a graphic card, GPU for the monitor, and a SATA controller for the hard disk. Okay, the last one is input-output interface. Connection standards such as USB, SATA, and PCLE that allow the device to be connected to a computer. Okay, let's move to next slide.
Okay, it's a input output device. Okay, input output device. There's device allow users to send data coming to the computer and a keyboard, mouse, and microphone. And output device that display or project information from the computer to the user, including monitor, printer, and speaker. And that's why storage device used to store data permanent or temporary, such as solid state drive, SSD, hard disk drive, HDD, and USB flash drive, and also M.2. Okay, next move to next slide.
So input and output controllers. Think of a computer as an orchestra without a great conductor. everything will be a mess. That is where is the graphic cards and SATA controller come in. Especially the graphic cards. The artist of your computer, it ensures that your screen displays smooth and stunning visuals. Whenever you are gaming, editing, or just scrolling through the social media. Data controller, the speedy of data courier, it act like the delivery guy, especially like Foodpanda, Grab, like that, JNT, making the sure the data flow efficient between the CPU and your hard drive or SSD without delays. Without this controller, our computer will not run smoothly. So let's appreciate them and dive into the world of input-output controller together. So the graphic card is basically used for the like for you playing game. Of course, you want to get a good graphic, right? So that
Yeah.
is the one. Okay, so the SATA is like so for the transfer data. But of course, you want to transfer data smoothly without have any trouble, correct? Okay, let's move into the next slide. Let's go, Ihsan.
Alright, thank you, Irfan. So another input output, we have USB ports used for connection, device like keyboard, mouse, and external storage driver. USB is widely used because it supports multiple type of device. And another input output is VGA and HDMI ports. Oh, use this I/O used to send video signal to monitor or projector, providing clear and high quality display. Without this interface, device would not be able to communicate with the system, making them essential for hardware and software interaction. Okay, next.
So this is the slide about the data transfer technique. In computer system, which are method used to move data between CPU and peripherals device. The slide highlight three main techniques. First one, program I/O. The CPU actively controls data transfer by executing instruction, which can slow down overall performance since it constantly check for data availability. And second one, interrupt driven I/O. Instead of constant monitoring, the CPU notify by an interrupt when data is ready to be processed, making it more efficient. The third one is direct memory access. A specialized controller handle data transfer directly between memory and peripheral without involving the CPU, significantly improve the speed and efficiency. So let's move the next slide. Let's go, Andom.
So for technique number one is program input output. In this method, the CPU directly manage the input output device by constantly checking its status. So this technique have advantage and disadvantage. And for advantage is it's simple to implement since the CPU directly controlled by the device. So for the disadvantage, inefficient as the CPU is busy waiting and cannot perform other tasks. So this is let's move to technique number two.
Okay. Technique number two. Interrupt primary I/O input output. In this method, the device can interrupt signal to the CPU when it's ready to send or receive data. The CPU can perform the tasks in the meantime and only reach when the signal and they interrupt. Okay, advantage, sustainable for system with multiple input-output device. More information and the program IO and field is not which style especially the device. The advantage is so very central. Focus centrally, the system needs to not. And what to next? Right.
Okay, thank you, Faris. So, uh, let's talk about direct memory access, aka DMA. Normally, when transfer data between memory and a device, the CPU is involved in the process. However, with DMA, device can transfer data directly to or from system memory without requiring CPU intervention. Advantage of DMA, you can free up the CPU. The CPU can focus on other tasks instead of handling data transfer. Disadvantage of DMA is more complex setup because even though it is more complex, DMA is significantly improved system performance, especially for high-speed data transfer device like storage driver and graphic card. Okay, so let's jump to another next slide. Next slide. Okay.
Challenges in input output design. Performance bottleneck. Slow device can reduce the overall data transfer speed, causing inefficiency in the system. So, Andom?
For challenges in scalability is adding more device can create communication chaos and slow down the system.
So the
Uh,
latency is the time taken for the travel between the device and CPU, causing the delays. So at the bottom, there is an illustration that visual represent the idea of tangle overload connection, symbolize the challenges facing in input output.
Solution to input output challenges. Uh, Number one, buffering. Temporary data storage for slow device, ensuring smooth system operation. Okay, Ihsan?
Okay. So second, advanced architecture. Technologies like PCIe and NVMe enable faster data transfer speeds, improving system performance and escape scalability. And lastly, uh, prioritization, assigning a high priority to critical device like the monitor, ensuring important tasks are processed first. This helps maintain a better user experience and system stability. In conclusion, I/O architecture plays a clear role in enabling communication between the CPU and external device efficiently. By implementing solutions like buffering, advanced, advanced architectures, and prioritization, we can improve system performance and reduce delay. So that's all from us. Thank you.
That's for us today. Thank you. So there's a
Alright.
kata-kata hikmah for us.
thank you.
Kata-katanya, guys. One,
A great
two,
system.
three. A great
A
system
great system will
is built
is
not
built
by the strongest component,
with just component,
but by
but
how well
how well
they work
they
together.
work together.
That's all for today, guys.